So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing Leetcode daily problem of map of highest peak, and in this problem we have to given a integer matrix is water of size m cross n, and the representation of the map of the land is we have given a land and a water cells, and these are two conditions. And if the water of ij is equal to 0, the cell of ij is our land, and is water of ij is equal to 1 of the cell of ij, uh, this is called a water cell. And you must have to assign each cell of a height in a way to follow these rules, and we have to given these three rules. And after that we have to return the maximum height of the size of m cross n, where height of ij is a size cell of I comma j, and we have to return any of them. So now let's look at their problem statement, and then we have to look their example test cases and coding implementation part. So here we have to given a matrix of each water and the size of m cross n. And so first we have, if the is water cell either a land and either water. So if the land is present, then we have to initialize with 0, and the water is 1. And water cell have a height of, this is height of 0, and the height of their adjacent cells differ by at most 1, and like we have given here, and at most 1. And also we have to given the maximum height of the grid is maximized. We have given these conditions. Like first is our water cells have uh, have a weight of 0, and the second one is we have their height of adjacent cells differ by at most 1, and the third one is we have the maximum height of the grid is maximized. The grid is maximized, and these are our three conditions, and the task is to return the grid with the assigned heights. Like we have to assign with 0 and 1, and after all these operations we have to return their assigned heights of the grid. And now observation of this question is, so the observation is, first we have their water cells start with their height 0, water of height is 0, and the second one is the land cell highest depends on their distance from the nearest water cell. Like we have to given a grid, let's suppose this is our 0, and after that we have update this, let's suppose this is 1, and after we have to check with their neighbors. These are their neighbors, and this is out of bound, this is out of bound, and these are their neighbors, and we have to update the values by using these conditions. Okay, so we have to check with their valid condition if I less than n, I greater than m, and so on. These are our conditions to follow on. We have to check their highest distance between their nearest water cell, and this is to find nearest cell. And the third one is we have their height is propagate outwards of the cell, water cell, increase by 1 for each layer. Like whenever we have to update the nearest cell, this is initially with 0, and after update the value is this become 1, and this also become 1, and after this value we have to update with their nearest, and this becomes 2 and this becomes 1, and so on. We have to follow up these conditions, like we have to propagate the water cell and increase each layer by 1. And the fourth one is using we are using for BFS, multi-source BFF, like whenever here is also be a water cell, then we have to find this one and this one also for separate. So we have to use multi-source BFS. So multi-source BFS is generally used for to find multiple paths, and we have to traverse with multiple values, and so that's why we have to use multi-source BFS. Ensure the distance from the water cell, shortest distance from the water cell and water cell to land. Okay, this is water cell to land, and after each cell we have to compute with BFS, and all neighbors are current level, like before, like first all levels are their current value, like first we have to initialize with 0. This is their current value. So these are our 4 observations for this problem. Like first we have their height, water height, and find their nearest value, and we have each layer with increase by 1 plus 1, and the last one is we have to use BFS for traversing all these valid paths. So now let's look at their example test cases. So here first we have given here uh, 1 0 2 1. This is our answer, and the is water condition is here we have 0 1 0 0. We have given here 0 1 and this is 0 0, and this is our output is 1 0 2 1. And so now how we can achieve this one. uh, so first we have the initial state. The initial state is we have there uh, this is our init, and this is our, so here we have their first we have their water cell, and second one is our land cell, and this water cell is generally where the water is present. So here only one water is present, so the whole cell is our water cell, and this cell is our land cell, because here is no any water is present. So this is our water cell, this is our water cell, and so this is our land cell, and this is our initial state. So now let's track with their values. So first we have to start with BFS for all water cells. Start BFS. So BFS we have to start with this value here. This is our water cell. So which position this cell is present? 0 comma 1, and so the starting cell is 0 comma 1, and the height of this cell is equal to 0. So now initially what is our Q? We have to using to Q with their BFS. So the Q is initially 0 comma 1 comma 0. This is our height. Okay, you can say this is our depth, and so here we have their row. This is our column, this is our depth, and this is our initial Q value. And the second step we have to follow, we have to process these values like 0 1 0, and assign the height of 0 to 0 comma 1, like this height. This is our height, and this is our 0 comma 1, and this is our initial position for water cell. So here we have the height of the height of 0 in to 0 comma 1, and at now we have to add its valid line neighbors to the queue. Here the neighbors are, these are our their neighbors for, and this is their neighbor, this and this is their neighbor. And so here what we have to get here, the position of this is 0 comma 0, and the position of this one is 1 comma 1. And so we have to get here two neighbors of this conditions. And you can also also look here, like this water condition is uh, only going these two conditions, this one and this one, and these are our out of bounds condition. Okay, so this is our left side, this is our downward side, and the right side and upward side is like this is the right side and this is our upward side, and this is our invalid condition. So we have to follow only these two conditions, 0 comma 0 and this 1 comma 1. So now what we have, our queue is, so first we have 0 comma 0, and so this is 1, and the next is we have there 1 comma 1 with depth 1, and the updated grid is, we have update, we have to update this grid, this remain same, and we have to update uh, 1 second, 1 comma 1, 1 comma 0, 1 second, we have update with 1 comma 1. Okay, okay, so we have to update not this, not this one condition, we have to update with this condition. Okay, for mismatch at that point, so we have to move here and here. So now we have to update the grid of this, we have to update the grid here, this position, and here remains same. Okay, and so now the next condition we have to follow, process with 0 0 comma 0 and with 1, this is our depth. So the third process, we have process of 0 comma 0 and the 1, and we have to assign height of this 1 to 0 comma 0, and we have to add its valid land to the neighbor cell. So what we have to get here, we have here two neighbor cells. So we have the 1 comma 0 comma 2. So we have to assign with these values to their position, and we have to add them, like we have their updated grid is 1 comma 0, and this one we have to update like this one, because we have to move here, and we have to move here, and the same thing for move here to move here, and so we have to uh, visit this condition, so that's why we have to update this cell, and this remains same. And so now our queue is 1 comma 1 comma 1 and 1 comma 0 comma 2. So now we have to update our grid, this one is here, and this one we have to update here. And so last we have their step 4. This step we have to process 1 comma 1 comma 1 and assign the height of 1 is equal to 1 comma 1. So we have to add its valid valid land, their neighbor. So we have to get here 0 1 comma 0 comma 2, and the updated grid is 1 comma 0, and this one is updated. So here we have also discussed, here we have to update this one. So the same thing we have to get here, and the q value is, this is our q value for after update. The q value is 1 comma 0 comma 2, and so the last step we have the value of 1 comma 0 comma 2. And so now we have track all these conditions, like we have to visit this one, this one, this one, and this one. So at that point time we have nothing to traverse. So we have assigned the height of 2, assign the height of 2, this height of 2 of 1 comma 0, 1 comma 0, 1 comma 0, and the final grid is, we have 1 comma 0 and this 2 comma 1, like we have also updated here, and this value is updated 2 times. Okay, and so we have achieved this one, like 1 0 2 and 1, this one 1 0 2 and 1. So these are our steps to follow all these conditions. And now let's look at their example second, for you have to understand how we calculate each conditions and their updated terms. And so first you have to look their visualization of example 1. So the visualization of this one is, first we have to traverse 0 comma 1 comma 0, uh, and we have to start with this one. Okay, and so next we have their updated values are 1 comma 1 comma 1, and this 1 comma 1 is our this value, and second we have to traverse 0 comma 0 comma 1, and this 0 comma 0 comma 1 is this value. Okay, so we have traversed with their neighbors. These we have initial condition, here we have to traverse with their neighbor values, and the third condition we have to follow 0 comma 0 comma 1, and this one we have to update, like sorry, this one we have to update 1 comma 0 comma 2, because we have to up height of 2 is, like update, we have to update the height, and this is our level 2, level 2 sorry, level 1, and this is our level 0. So we have to traverse with this one, so level 0 plus 1 we have to follow here, and so this is already a level 1, so here we have to update with this one to, this one is 1 plus 1 is equal to 2, so that's why we have to update into 2. And so last one is, we have this one 1 comma 0 comma 2, and after we have to coordinate, we have to check their coordinate, all neighbors are either out of bound and all neighbors are already visited, like here you can say, here they already is visited, here already is visited, and this condition is visited now, and so no any further conditions we have to satisfy or we have to follow. So that's why this is our last process we have achieved, like, so now the after q we have nothing to here. So the final height, 1 0 and 2 and 1, this one. So I hope you understand the logic and their visualization part. how we track the BFS condition and how we track their queue. And so now let's look at their um, coding implementation part, how we can implement this whole idea. And here first we have their dimensions of grid, and these are our dimensions, and these dimensions we have to follow up our all all their loops. And first we have to track this visited array, to track processed cell, like which cell is already processed and which cell is not processed yet. So this one we have to follow the valid visited condition, and the answer is generally result the array of height. And this queue of vector is this is BFS queue for process all the cells. And now here we have to initialize the BFS with the water cells, like here this M, this N, we have to initialize a BFS with a water cell. And this condition is if is water of ij. This condition, if the cell is our water, so we have to check their condition and we have to push their into a queue. And queue is with their height, initial height of 0. And so that's why here we have to already set with 0. And if the if the cell is visited, then we have to mark as 1, and else we have to also declare with false is 0. And so now uh, this is our main code and their implementation part, how we actually solve this problem. And these are our dimensions. First we have a four-way dimension. These four-way dimensions, first we have north, east, and south and west. And and after that we have to running a while loop for whenever the queue is not empty, then we have to iterate our this loop. And we have here the explore the neighbors. And like these neighbors are we have their up, left, right, and down, and north, south, east, west, and the same for these one. And only we have their four valid path. And so here we have the valid condition we have to set check, like out of bound condition we have to also check on this if condition. And this visited of nx and ny, and it is a visited condition. And this answer of nx comma ny, it is assign the height. And after that we have to push and add their neighbor queue and neighbor queue. And so after that we have to return their answer. So the logic is generally we have assigned their dimensions, and we have also set and initialize with their BFS values here. And after that we have their q value. This q value is our tuple, like we have I comma j comma their height, and you can say their depth. And these three value we have to traverse with their q. And these q we have follow up these valid conditions. And then we have only if the cell is visited, then we have to move further, and directly we have to return their answer. So now let's look at their time and time complexity and space complexity. So the time complexity of this code is, first we have used BFS traversal. So the BFS traversal is generally used for O of m cross n, this one. because we have to use nested for loops, and for each cell we have processed one time, and the overall time complexity of this code is O of m cross n. And same thing for, we have to find their space complexity. First we have defined their queue, and we have also be a visited vector, and this visited is generally for O of m into n, and for storing this visited cells and queue element. And this is the space complexity of this piece of code. And now we have also declared a result matrix. This result matrix is O of n m cross n, m into m, and this is storing the height, and overall is m into n. So I hope you understand the logic and the implementation part of this code. So thank you everyone, thank you so much.